Okay, so hello everybody. Thank you for welcoming here. I'm also working for the same company, so it looks like it's a conspiration somewhere. No, I think everybody in HP is interested by continuous stuff, continuous integration, continuous packaging from my side. So I'm working I'm based in Europe, in France. I'm part of a solution center where I'm hosting customers and we do a lot of tests for them around the Linux and open source for my activities. And I'm involved in a certain number of internal other activities inside HP as well as external projects. And I started this specific project builder project 6 years ago now, 8 years ago. In fact, when I found out that I was in need of a continuous packaging approach for my other project, which is a disaster recovery solution. So I will try to explain to you what it is and see if it's useful for you. Are there any people in the room who are upstream for a project? Okay, so all the other can go away because it's mostly for upstream people. Are some of you packagers for distributions? Yeah, mostly the same. Interesting. Okay, so really this talk is for people who are mostly upstream people and interested to make their application packaged and having the easiest way to do that. Really, I want to help you as upstream project to make your life easier packaging your software, but it does not start like that. It started as a selfish stuff. I wanted to make my life easier to package my own projects. And everybody has its own itch to scratch in that perspective, and that was mine, so 8 years ago. So if we look at some SourceForge statistics, if you go there and you look at what people are downloading from SourceForge, you will see that most of users and system administrators, in fact, are much more interested by getting packages for an application in order to install it on their system, rather than to deal with tar files and the magic configure, make, install mantra, or even worse, going into a Git repository and a Subversion repository, Mercurial, Bazaar, Hazard, I don't know which one they are using, but going into the repo and doing the magic commands to extract the software from the repo, compiling it and installing it on their environment. So that does not seem to be very much popular for end users or system administrator. Why? Because they want to use their standard tools to manage their environment. They don't want to pollute their environment. They want to have an easy integration of the packages inside their current existing environment. So they want to make their own life easier, to be in compliance with their distribution and have stuff easy on their side. When we look at developers, the story is completely different. They are interested by the repository most of the time. Some of them are in charge of making release of the software, publishing tables on an FTP site, on an HTTP site, and letting people download the software. And very few, some projects have people dedicated to do packages, upstream packages, but most of the time these tasks are left for distribution packagers. So people from the Debian project, Fedora project, etc., take the software and make packages out of the software, which creates some issues from an upstream project perspective, is there is often a lag between the release of the software and the release of the package. You have much less coverage in terms of alpha, beta version of your software. When you have reached a certain point, you may want people to test your software to check if the development you've made is really fixing the problems that they have reported on your mailing list. And of course, it's in your Git or Subversion or whatever repository, and it's difficult for them to have access to that and to give you feedback most of the time. So especially when you are a smaller project and you have people who are not IT savvy or not that IT savvy who are using your software. So it's sometimes difficult for you to have feedback on intermediate versions. And for you as an upstream project, it's very difficult to cope with the number of distributions, the number of versions, the specificities of each version of each distribution, the package formats, which are multiple as well, and having their own specificities sometimes, and the tools that you need to learn to generate all those packages if you want to cover a large set of distributions, because you want your software to be popular, so you want your software to be accessible into Fedora, OpenSUSE, Mageia, Mandriva, Ubuntu, Debian, Gentoo, and the 200 others that you can find on DistroWatch if you look at them. So, and you want also to manage the repositories associated with all those packages to make the magic apt-get install or yum install or urpmi install very easy for your users. So all that makes your life difficult as an upstream project maintainer. So, however, as I said earlier, it's really interesting for you to be able to provide your software as long as you are developing on the fly, because that way you can have more feedback. You can have your software more used by people and get more feedback from your users as you are developing your software. So packaging continuously as you do test continuously or as you do integration continuously is really a value add, I think, in a development environment, and should be a technology, should be an approach which is more popular across projects. And it should be, in my opinion, a concern of each upstream project, as well as coding, testing, installing, having a good installation procedure, which is in link with the packaging, in fact. Personally, I use packaging as the only way to deliver software to an environment, myself for testing or customers or whatever. I don't want them to install a US or local configuration file which will interact with the etc configuration file which may break the environment or the test you're making or whatever. So I seen head nodding because it happened to everybody. So having only packages as a way to deliver the software, it's a good way to avoid those type of mismatch between different configuration environments, and also to ensure that your software production chain will be consistent from the start of the development up to the end of the development. The end meaning that you're delivering a product to a customer. Whatever the nature of the product is, as the nature of the customer is. Even if it's a hacker or even if it's a paying customer, it's the same. The level of quality should be the same. It does not matter who he is. And it's really not a big overhead to do packaging at the same time as you are doing the rest of the development. Producing a tarball, compressed tarball, or producing a package for a set of distribution, especially when you're developing for your own platform, making that locally is very easy. When you start producing, as I do, 120, 130 different packages for different distributions, versions, and architecture, then it takes a bit more time. But I do that at the end, when I'm near the release. For the rest of the life cycle of the project, I just use the native packages. So it provides to you a certain number of benefits, which is it's always consistent, it's always reproducible. Of course, you can have bugs in your packages as well as you have bugs in your software, but it gives you a better integration, better ability to deploy the software, put them in a repository, have your testing environment pointing to various versions of the repository, to make the tests, etc., etc. So it's much streamlined compared to manual approaches in that environment. And again, you don't risk to screw up your system by installing packages instead of installing standard files. One other point to consider for upstream projects, especially for small projects, having packages is also a marketing activity. It's a technical marketing activity, but it's a marketing activity in the way that you are promoting your software by providing an easy way for your potential users to use your software. It's as easy as apt-get install. So it makes their life easier, so it makes the popularity of your application more important. It allows you to have more users, more testers, and more people adopting your software if it's a good software, hopefully. So you can see it as a competitive advantage with regards to other projects who do not do that. So my new mantra is package early, package always. And I really think that doing continuous packaging is as important as the other continuous activity, whatever the tool you use. And there are multiple tools available that can help you in that perspective, depending on your approach around the development. So if we look at the architecture, which is supported by Project Builder, you have the developers working on the project. You may have some people dedicated, could be the same, could be different people, working on the packaging of the project. It could be a separate repository if you completely split the team or split the activity, because you could be not an upstream project. You may want to use Project Builder to package applications for which you are not upstream. It's also working. Both have their own repositories, and both produce tar files which contains all the information needed to package the application. So the application in itself, and also all the build information and metadata around the software to allow you to create all the packages. Then you can use a farm of physical machines, virtual environments, the way you want to build the software. And once you have built the software, you get the packages, and you can push the packages to a software repository and build all the indexes that you need in order to make it work. I will make a short demo to make it a bit easier to understand, but that's roughly the way it's working. And you see also one point that I didn't mention earlier is that it's not only working for different Linux distributions, but it's also working for Solaris, and it could work for any other Unix-like operating system. Don't ask about Windows support. Well, there is a WinPKG software which could make it very similar to what exists on Linux, but I never tried to integrate it. Okay, maybe we don't want to go into that level here. So what are the goals of the tool? The goals are to allow you to be quite agnostic with regards to the environment which is used by the project. The project started for me as a couple of shell scripts written to just automate the build procedure of the hundreds of packages I wanted to produce for the Mondo Rescue project. But I was contacted by other people who said, your approach is interesting for us, we would like to use your tool, and I realized it was not really a tool, it was really a set of scripts wrapped around my project. So I rewrote everything from scratch, taking into account the fact that other people than myself could use different repository, different configuration management system or version control system. They could use different operating system and target operating system. They could use different build environments, and they don't want to have any impact on their upstream project. So Project Builder is really supporting a lot of VCS now. I'm working personally with SVN a lot and Git a bit, and Git SVN in fact also. SVK was working out as well. CVS Mercure was working for 2 other projects. So it builds for a large set of different Linux distributions. And it's interesting how you can learn stuff trying to build for so many different environments. They look similar, and they have a lot of small differences as time passes as well. So I've started 8 years ago, so now I have, for example, from Fedora 6 up to Fedora 20. And it made a lot of changes during time that you need to support, that you need to take into account. I'm building locally most of the time on my own machine. I'm generating my own packages, installing them, and making the test with that environment. When I need, for example, to provide a patch for someone on mailing list saying to me, I'm running in that environment and it's not working, then I make the patch. I create the packages for that target platform. I publish them in a test zone on my FTP server, of the FTP server of the project, and people can download it and use it very easily. And for that, I use a certain number of VMs. I have 120, 130 VMs on my machine. So not the laptop here, I just have a couple of them here. but at home I have what I need in order to produce all that. It's just a matter of having a hard disk which is big enough, in fact. There is no special difficulty in doing them, and you don't need to maintain them, by the way, when you're running them, because they are fixed in time, and you just want to build for those. And you don't want to put any impact on the project, the upstream project, because there may be a completely different team. You may want to package using Project Builder for a project which is not your project, for which you are not upstream, so you can't force them to adopt anything except their standard build process that they have. So you need to use what they provide to you. So even the MD5 sum of the project should be the same. And one of the goals, which is very important for me, was to avoid duplication of code or metadata. We'll see later on that in each package format, you have similar type of metadata which are asked to build your package. And you don't want to repeat yourself when you say, this is a summary of my package, a summary in Debian, a summary on an RPM package. It's the same sentence. You don't want to duplicate that sentence. So the tool provides you macros in order to help you keeping those information unique and helping with the maintenance. In addition to that, so I have 130 VMs. I need the tool also to help me managing those, especially creating them, because once they are created, I don't want to update them. I want a RHEL 6 to stay a RHEL 6 or a Fedora 6 to stay a Fedora 6. I don't want the update mechanism to change it to Fedora 7 or whatever. So I need tool to help me with the installation and setup of the VM. The VM needs to, or the remote machine or shroot environment, they need to have the tool installed in them. So I produce the packages for those distribution. I put them on my server, and from the FTP server, then the VM can update themselves and get access to the software. So as I said, there are macros available to avoid the code duplication. When you start a project, you can have a skeleton of all the infrastructure of files which is given to you as an example, and you just need to fill the missing pieces, which helps you because when you are an upstream project, you are not a specialist of building RPMs or building DEB. Or even if you're a packager for a distribution, generally you know well that distribution, but much less well the other distribution and the other packaging mechanism. So the fact that you have a skeleton and that there are macros already predefined, you just need to put the content in it, helps you build the most correct software from the first point that you created the infrastructure. You can go up to managing the repository. So you deliver all the packages, and then you create all the indexes that are needed by YAM, APT, or your PMI to support the magic sentence of command install my stuff. And I have some other goodies, such as managing announce for the mailing list when there is a new version, some tests, integration, some support for add patches, because if you are not upstream, you may need to add patches to the software you want to build in order to build it correctly for your distribution. So you need to support that. We are calling the tools of each distribution to check the validity of the packages that you are building. A certain number of nice stuff like that to help you, especially if you're not a specialist of this distribution, as it's done automatically by the tool. Then we try to put the best practices around package build inside the tool, instead of having everybody being a specialist of all the build mechanism for packages. So when we want to create shroots to build environment, we use Deb Bootstrap for Deb distributions, Debian, Ubuntu typically. And the project is providing an RPM bootstrap command, which looks like Deb Bootstrap, which works for Mageia, Fedora, Mandriva, CentOS, and OpenSUSE. For VM creation, up to now I'm using KVM, QEMU. So we use that with the ISO installation in order to create the content of the VM. And then there is a setup command which adds a project builder tool inside the environment, both VE or VM. You can use, of course, any tool of your choice to create the VM and use it as soon as you have set it up to be accessible through Project Builder. Then you don't have any specific problem with that. There are snapshot features, and to build inside a VM, in fact, from a Project Builder perspective, the tool is calling itself. So each build is local to an environment. Project Builder detects in which environment it's running. It knows which distribution it's running or which operating system, version, architecture it's running in it, and it is able to create the right packages natively for that environment. And so every time you build a package, it's always built locally. If it's in fact a remote operation that you want to do, then PB is calling the PB inside the virtual machine or the chroot to do the job and getting the package. So it pushes all the source at the start of the operation and gets all the packages at the end and does a push and the build of the indexes outside. Okay, you can't read it, me either. So if we take an example, I told you that each package format has its own, has a very similar set of metadata that they want to be filled in order to work correctly. Typically, Project Builder helps you with that. So you have, for example, the notion of filter in Project Builder, which the all.pbf is a generic filter which applies to all the distributions. And we will see there are inheritance mechanisms that allows you to distinguish it if you want. So you create a macro, which is PB summary, which gives you a summary of what the tool, your packaging is doing. And then inside each build format for the RPM, it's a spec file. You use the summary colon and the macro. For the Debian, it's a control file, which is description colon PB summary. For Solaris, in PKG info, you have name equal quotes, PB summary. So each one has its own format, but each one wants a summary. Each one wants a description, a version, a release, a name of the package, etc., etc. So you have a certain number, I would say around 10 metadata, which are always used by all the format, and then you have some specificities for each package environment. What is interesting for me in Project Builder is in order to try to avoid duplication, I introduce a notion of instantiation. So when you define the macro, you define them from the most specific up to the most generic. So if you have a macro defined for a distribution version architecture, this one will be used first. If not, if there is one defined for distribution version, then for just the distribution family, if all the Fedora, for example, distribution may have something in common that you want to place at that level. Distribution type, it's all the RPM distribution may have the same way of dealing with a certain level of metadata, or the operating system level if there is no more granularity possible below. And what we do here in an example can be done for all the parameters that are in the project, and main page of the configuration file is as detailed as it can to explain to you what you can do with regards to the inheritance here. So it gives you a lot of flexibility to avoid duplication as much as possible. There are a certain number of commands that I will not detail you, we'll have them on the slide. Just to map to how we are building. So generally when you start a new project or a new version of an existing project, which will create either the skeleton or duplicate a version into a new version in your repository. Then you will build from a sandbox or from the configuration management system files coming from the project for the data of the software, and the other repository for the metadata of the project. And then the second phase consists into taking those two build files and build a package from these build files using the build pkg command, which will create a native package, which could be whatever it is, that you are running as an operating system. Or the same command can be used build to VM or to VE or to RM to build remotely or in a shroud or in a virtual machine, which will be a local build at their level, production of packages, and all those packages at the end are pushed to your repository server, which will serve as base to do apt-get install, yum install, etc. I have some, so this is an open source project, GPLv2, it's written in Perl. I have customers who are interested by moving from Solaris to Linux, for example, and they want to keep in sync multiple branches of development for different environment. So they don't want to abandon Solaris, for example. They want to continue to be able to maintain the Solaris customers and at the same time develop a Linux branch. And having the fact that with us, so we are providing other tools that I will not explain here, which is a wrapper library, which makes the for C, C++ development, which makes porting the software and having a single source code base for the software much easier. And on top of that, if you add the continuous packaging, it makes for them the life much easier because they identify similarly the same software and the same status delivered to their customer on the two branches. So that's one way of dealing with multiple operating system development. Any question up to now? Yes?
You support Solaris package. Do you also support Solaris new IPS and Solaris 11?
No, because I don't know that. I'm not a Solaris specialist myself. So what is it?
They've just changed packaging formats. They no longer have a single package file.
Okay.
Instead, it's a repository server that you add and actually pull the files on.
I guess it's linked to the fact that the PKG format did not have any dependency mechanism in it. So.
But now the new one does have dependencies and facets. And
okay. As in the previous talk, I welcome patches. Really, and it's really based also on the fact that I don't know myself all. So I'm a Mageia Fedora packager, so I know RPM much more than the other. I talked a lot to Debian developers to try to get the best possible information so that the tool behaves correctly with Deb environment as well. Solaris, I had to work for some customers, but I got their expertise to do what I need. So it's opportunity or interested people that can add support for new packaging system. If there are some BSD developer in the room, I would be happy to add BSD package support format for it as well. It's not really difficult, but it's linked to the knowledge of the packaging format that you need to have. Any other question? Yeah?
Does this make source packages? Or?
Yes. It makes source packages and binary packages. All the packages that the distribution you use, the operating system you use can generate, in fact, because it's calling the native tool. It does not do any magic with regard to that. So it's calling RPM build, it's calling dpkg, I don't remember, it's in the tool. And it does a job just calling the right tool and passing the right spec file, control file, rules files for Deb, so that it's transparent from that point of view. So if you already are building packages and you already have the content, it's quite easy to put it under that format and benefit from the genericity. So to wake you up, some demo, maybe. So there is always a demo effect problem. So first I need to find my mouse, then I need to okay, so we will go into so I will show it to you locally how it's working on my laptop, so bear with me, it's not really working as fast as it is on another machine where I'm generally building. Okay, so I have here Project Builder itself, and I have is it large enough? Do I need to? No, okay. So I have my development tree here, and I have my various versions available at that point. This is a mirror of my Subversion environment that I access through Git, because SVK is not working anymore, which is too bad, but that's another story. So for example, if you look at information on the repository, so you see the Subversion revision ID, which I like a lot, because it gives to me an information I can't find really as easily as in Git as in Subversion. But I don't want to speak about that yet. So if I query the system to say, okay, so this is an RPM-based system. This is Mageia distribution. You don't know it, but it's not a problem. It's just an RPM-based distribution. So if you query the system, you can see that the package called Project Builder, which is a development version, has been built today at 6:57. And the goal will be to rebuild the package, so that I can show you. So same information from the tool itself. The tool gives you its version, so we can check that it's exactly the same version. By the way, if you call it alone, it gives you a bit of information around all the commands which are available inside the tool and the options that you can pass. So we will start by, where's the pipe? We will start by just building locally. So what I ask the system, the project builder to do is, okay, this is a command, this is a project on which I want to work because I can work on multiple projects. So I want to work on the project builder. I want to work on the branch, which is Devil. And I want to build from my sandbox here. I want to build. So this is the first step of generation. So it analyzes the action, the project. It finds that there are 4 packages to build as part of this project. And you can see that it's building a lot of build files for the various distributions that I'm using. So all that is configurable and part of configuration files I will show to you later on. At the end of this step, for my 4 packages, future packages, I have created 2 times 4 tar files. So the first is just the project itself. Whoops. Which is not very, well, it's normal. There is just one Perl script in it, and the rest is the classical set of information and the Makefile to build it. So this will be, if I'm upstream of this project, I will just publish that tar file normally. No difference with that. The difference comes with the other package, the other tar file, sorry, which is here. And that tar file contains, of course, come here. Okay, it's not even better. Okay. So that tar file contains all the build information for all the distribution I'm supporting. So for example, for each, so we can't see the end here, but for each RPM-based distribution, so SLES11, Mandriva, Mageia, RHEL, it has created one file, which is a spec file, which is instantiated from the template I have, applying all the macros, respecting the inheritance mechanism to generate a specific spec file for each RPM distribution. I have a single spec file that I will show to you later on. I have a single spec file available, and just by the different macros, which are defined, undefined for different distribution, I generate the right spec file for the right distribution. Similar for the Debian or the Ubuntu distribution, I create the rules, I create the control file, and I create all the other files that are needed for each Debian distribution in order to have it built correctly. Okay, so now we can go to the second phase, which is build the package from the tar files which have been created in the first step. So it's creating locally a certain number of packages, and you have errors which are reported. The first set of errors is because I don't have my GPG key here on my laptop, so it cannot sign the packages as it should. And the other is RPM-lint, which has a bug on French special characters in the spec file. But those are harmless errors. And at the end, it generates for me the source packages and the binary packages. So just calling RPM build as usual. So now I can say, OK, install for me all those packages. And there is an option into PB to do that automatically at the end of the process. And so, OK, URPMI said to me that the package are not signed, which is obvious because I don't have my key here, and it does the installation of other packages, and taking a bit of time with the RPM database. I don't know exactly why right now, but in a couple of seconds you will see installation of the packages coming out of the software. So this is the way I'm using it locally on my system. I always do that to generate the software and test it. Excuse me?
Yeah, we'll probably go that. A minute or negative a minute?
Negative minute? So just the last one. So just to check that we have indeed the new version. Okay? So it's 9:53. Of course, because it's French time. And now we can do exactly the same for, so if we have need of time, I will do it for a Debian distribution locally in a shroot. So my shroot is already available and ready here. What I just asked Project Builder is just the same command, except that I need to give it the name of the virtual machine, virtual environment in which I want to build, and the command is sbx2ve because I want to build in a virtual environment. So it starts the same. It's building the 4 times the 2 tar files which are used, and then it's sending all these files into the shroot, preparing the shroot environment, making some show and stuff like that which are needed, and launching a script inside the shroot environment, and that script is just calling Project Builder inside the shroot environment. And setting up some environment variables and calling the tool directly. And then, so you have a prefix with the Debian 60x8664, which is the environment in which I'm building. You can build in parallel on multiple virtual machines if your hardware is supporting that. And then you have the log of all the generation of your deb files for this platform. Then at the end, there is a recovery of the packages from the shroot into a temporary place, and then it's propagated into, whoops, let me go here. It's propagated into a local, in fact here a local because I didn't want to use the network, so I'm not pushing to my real FTP server, but just on the local FTP server, and then it calls the apt archive command, apt FTP archive command, in order to create all and scan packages, in order to create all the metadata which are associated with the packages. So at the end, you have in that directory, you have also an apt source list file. You just download that source list file, and you can do apt get install of your software. And with that,
you can go out get source, but you can't go out get install. It's only source.
Installing that.
If it's only source, you can't install it. You can go out get source, but you can't say get installed.
I don't have only the source. I also have the all that packages If you see this one is a binary package, but it's not a binary package for Debian. It's a no architecture.
Yeah,
It's available on because it's a Perl script. Okay, and with that, I think. So I need to pass just one last slide because I made it extra for this. So there is a special announce for LCA 2014, which is a version 0.12.3, which has been made this morning and which is buggy, of course. It's buggy because I don't like time release. I argued with Mark Shuttleworth once about that. So it has bugs. It has bugs I found when I prepared the demo for this session, and I didn't have all the time I needed to test. Even if the flight to come here is quite long from France, it was not sufficient to test everything correctly. So I really hate time release delivery. So expect 12.4 this week later when I have time to make more tests. And I really hate time release delivery. So it will be a feature release delivery. There is more work to be done. There are docs on the wiki that you can find. You have all the links in the presentation. There are other tools performing the same stuff. OpenSUSE build system is available, and a lot of people are using it also to create packages. It's a bit different because it's more a service. Project Builder is more something that you can use yourself inside your project. Completely without relying on an external service to build your software. And with that, thank you very much.
Cool, thank you.
Welcome.
Some of you are speaking in the room and everything.